I'm Lior, and thank you for joining me today. I'm going to be talking about Julia, the new language for scientific programming, or from a business perspective, this is basically data science. What is Julia? Julia is a high-level, high-performance, dynamic functional programming language. So I actually come from an engineering background, and these are the tools that I first learned to code with, Python and MATLAB. These are very popular for scientific programming because they're very easy to learn, they're very powerful, and they're very easy to use. However, a problem with both of them is they're a bit slow, and it can be hard to maintain large code bases because there's a lot of freedom in them. So Julia, I really like it over these other languages because it's flexible like Python and MATLAB, but it's also got some rigidity like static languages. Julia is a functional programming language, but it's not as pure functional as Scala. You'll see that in a moment, but that is something to keep in mind. Okay, so Julia is a relatively young language. Python is more than 30 years old. Julia was only released less than 10 years ago. Version 1 was only released 3 years ago. And here you can see the reasons why the founders wanted to make this new language, because they wanted all the benefits of other languages, the speed of Ruby, as usable as Python, as powerful for algebra as MATLAB. And for the most part, I think they've actually gone and created a language like this. But exactly like Jared just said with Dino, Julia is a young language, and it's not as mature as Python. I mean, it's less than 3 times the age. So yeah, that is one disadvantage. The community is not as big and there are not as many packages. And just to really hammer this point home, this is from the Stack Overflow survey from last year. Python, more than 44% of respondents said they loved it. Julia's right down at the bottom with 1%. And the local situation looks very similar. Almost 40% of local developers said they liked Python. This is an Office End survey. And only about 1.7% said they wanted to work with Julia. I think this is really sad though, because Julia has lots of great features and which make it really unique and really powerful. So I'm going to be doing a demo soon where I show you some of these features. I think the first two is that it's just in time compiled. So Julia is a compiled language. It's not like a statically typed language where it compiles everything at the start. It compiles it when you need it, hence it's just in time compiled. And also it has this really cool feature called multiple dispatch, which makes it really easily extendable. So the first part of my demo is going to be on multiple dispatch, and the second part is going to be on just in time, just how much faster it is than Python. So what exactly is multiple dispatch? Well, actually, in Julia, when we talk about multiple dispatch, we actually mean it's a combination of 4 different things. It's function overloading, which a lot of other languages have, like C++. But yeah, function overloading, robust typing system, dynamic programming, and functional programming. And all of these together give you multiple dispatch. And I think a lot of languages have some of these features like functional overloading and robust typing system. C++ definitely has that, but no language really has all of these features except for Julia, and does it as well as Julia. Well, okay, that's my opinion. And now this slide here I've got is from a talk by one of the founders. And what's happening here is, I think, something just short of incredible. There are 3 separate packages which are being used together and integrated, and they're all working seamlessly together, even though the creators of the package didn't know about the other packages. So the first one defines a new number called measurements, which adds an error to it. The second package solves a differential equation, and even though it didn't know about the errors, the little error attached to it, it can solve it because of the power of multiple dispatch. And then you can then take this to a plot, and you can plot those error bars which have been calculated through the differential equation. Okay, so if you're a little confused with how this all works, I mean, multiple dispatch does sound like a complex system, but let me actually go and make a demo. Wait, I've lost my screen here. Okay, so this is actually what Julia is. So I want to, I'll give a quick example of how multiple dispatch works, and you'll see it's actually quite a simple idea. So as I said, Julia is a dynamic programming language. So if we have x in this type of integer, and then we change x to another type, for example, a string, then it will automatically reallocate that variable. However, typing is more important in Julia than it is in, for example, language like Python. I think the best way to show this is within an array. So this is an array of type any. Okay, and here you can see I'm pushing something to it. And you can see the functional syntax coming in, because you don't say dot push. Functions act on objects. Objects don't own functions. So that's the functional programming coming in. But here I can push a number to this array, and I can also push a string. However, I can make an array that is exclusively for numbers. And then this numbers array, I can push a 2, or I can push pi, or float, but I can't push a string. And I can make this even more restrictive, where I can make an array that's just for integers. Sorry, let's call that integers. And now I can push to integers 2 or 3.0, but I can't push a float. Okay. Types. So as you can see, types are quite important in Julia, and more strongly enforced in Python, but not as strongly enforced in your static languages. So that's what I said. That's what I meant by good balance between flexible and rigid. Okay, so I think the best way to demonstrate multiple dispatch is to actually use a function. So Julia functions live in a global namespace, but each function has a method. So this is the opposite to object-oriented programming, where functions are encapsulated with objects. Here they kind of live in a global namespace. You can assign different methods to functions. So rand has 68 methods, and okay, you probably didn't catch all of that, but these are just showing all the different things that we can call rand with. So for example, if we call rand with nothing, it assumes, well, it goes and picks up the function where nothing is passed to it, and then it returns a float. But if we pass a range to it, then it goes and picks up the version of, well, the method of rand with a unit range, and then it returns a number within that range. And if I add an integer to this, it goes and finds the version of rand which is made with a unit range and an integer, and then it returns 5 integers within that unit range. And what about if I try the other way around? Well, actually, there was no method defined with an integer first and then a unit range, so that doesn't work. So that's all multiple dispatch is. It goes and calls the function we want at the moment we want. Well, based on the arguments. So why is this great? So remember my numbers array. So I can easily go and define a new type of number. So I was actually working on something called quaternions. Doesn't really matter what it is. Anyway, and I can define it to be a new type of number. What? Sorry. Yeah. Anyway, so it doesn't matter what the quaternion is. All we need to know is that it itself is made up of other numbers. I'm not going to do this properly. Okay. Okay, that's not really how you define a quaternion, but that's not really important. The point is, I can now make a new number. Into my other, and I can now push this into my numbers array because Julia sees it as a number. So there was nothing stopping me from going up to this quaternion and say defining it as type string, but that wouldn't really make sense, and that's not really, doesn't really give the behavior that your user expects. But if I call it of a type number, then yeah, we expect a quaternion to act like a number. But let's say I want to add, let's say I want to add a number to it. Well, actually, the plus operator is also being multiple dispatched on, and I haven't defined how you add numbers to quaternions. But I can very easily extend this with a q-quaternion. And this is going to be a new quaternion of q. How do I define this? X q.v1. All right. This error I was actually expecting. Julia's safeguards methods, so we can't just automatically extend them, but I can import it, so and get rid of those guardrails. And now I can extend it. And now I can go and add a number, and there I've gone and extended the plus function for my totally new number. Okay, so that is multiple dispatch. I hope this gives you an idea of how you can easily extend functions and variables, and you can already see how that measurements package in my slide, what that measurements package in that slide I showed earlier did is extend all the functions like plus, minus, times for measurement, and then the differential package was able to know which sort of plus it had to call and to account for the error in that measurement. Maybe let me show that here. Okay, yeah. So hopefully this slide makes more sense, and you're happy with that. Now, if I have time, there is one other demo I wanted to do. So I wanted to give a demo of how much faster Julia is to Python. So this was a talk on Julia, not on data science and machine learning. But just to show quickly what I was going through here is a random forest classifier, and it was going through 54,000 entries. And then it's trying to determine whether or not a person was promoted in this time period, based on statistics like their region, gender, education, length of service. Yeah, so I'm not going to run through this code properly. The important part is the fitting time here, which, as you see, I've already pre-run because it took 180 seconds. So that's 3 minutes. Yeah, on a 15-minute presentation, I do not have time to wait for that. But what I wanted to show you, and just an important caveat, this is using my own random forest classifier. Scikit-learn's random forest classifier does run faster, but that's not written in Python. That's written in Scikit, and it's also optimized to work with threading. I just wrote a simple random forest classifier that wasn't as optimized. So Julia is very similar to Python. You can go into the exact same thing. The plotting doesn't look as nice as Python. I think that's just because it's, less mature, and that is something unfortunately I find a lot with Julia. But here we can go run it, and I am so confident of how quick this is going to take that I'm going to run it live here. Yeah. So Julia is a compiled language. It's gone and compiled this fit function behind the scenes and gone and made it. And it's not going to run quite as fast as scikit-learn, but yeah, there, we're done. 20 seconds compared to 180 for code of pretty much the same length. I think is quite a big improvement. Okay. That's well, thank you for listening to me, and yeah, I know that was a lot, but I hope you can see the advantage of Julia, and I really hope it's a language we hear about more in the future.